welcome to this episode of Mr. Layman's Knowledge Explosion. In Lesson 3, we're going to talk about trapezoids and kites and how they're different from parallelograms, yet similar at the same time. A trapezoid, by definition, is a quadrilateral with exactly one pair of parallel sides, unlike the parallelogram that has two sets. So we name those two parallel sides bases, so you have two of them, base 1 and base 2, and they're connected by the legs. And along each base you have what we call base angles, and there's two sets. So there's two angles along base 1 and there's two angles along base 2. Now a trapezoid by itself does not have very many properties. In fact, there's nothing but the definition and knowing there's parallel sides. But if I add a definition and I say I have an isosceles trapezoid, well, now that means that the trapezoid has legs that are congruent. With isosceles trapezoid, there are two theorems that I would like for you to know. The first one is, if a trapezoid is isosceles, then each pair of base angles is congruent. So I give you that ABCD is an isosceles trapezoid. You immediately know that angle A and angle D, that pair of base angles, are congruent. You also know that angle B and angle C, the other pair of base angles, are congruent. So that's theorem number 1. Theorem number 2 says if a trapezoid is isosceles, then the diagonals are congruent. So you can see in this trapezoid, ABCD, it's isosceles, and I've drawn in the diagonals for you. What you know right away is that segment BD is the same length as segment CA, much like a rectangle. So this is why we were unable to say that congruent diagonals is going to guarantee me a parallelogram, because it could be an isosceles trapezoid. So you have to think about what could happen, not just the properties. Now, we do have this one theorem about the mid-segment of a trapezoid, and a mid-segment of a trapezoid is the segment that connects the midpoints of the legs. So if point M is a midpoint and point N is a midpoint of the legs of that trapezoid, when I connect them, what I've created is a mid-segment. So you would know that MB and MA are the same, and you would know that CN and ND are the same. There are two properties that go along with that. The mid-segment of the trapezoid will be parallel to both bases, so you're going to get three parallel lines. And the second thing is the length of that mid-segment is half the sum of the lengths of the bases. And what that means is easier to understand with numbers. If AD was 10 and BC was 4, then MN is going to equal half of those two bases added together, or half of 14, which would be 7. And those are the two things I want you to know about the mid-segment of a trapezoid. If you turn the page, we can go through an example. It says TRAP is a trapezoid and MN is the mid-segment of the trapezoid. So in number 1 it says angle P is 85 degrees. And I'm supposed to find the measure of angle TMN. Well, I know that the mid-segment is parallel to the two bases of the trapezoid, and that's a corresponding angle, so TMN is going to be 85 degrees. The measure of angle PMN is the angle underneath. Well, again, if they're parallel, those are consecutive interior, and consecutive interior should add up to 180 degrees, so the measure of angle PMN is going to be 95 degrees. And that's how you're going to use the mid-segment to answer some algebra questions like that. Let's look at number 2. It says TR is 6, and it says PA is 12, and I want to know the length of MN. Well, that's the exact type of problem we just did. The mid-segment is always half of those two bases added together, or in this case, half of 18, which is a total distance of 9. You could work forwards, you could work backwards, you could do this with algebra. Let's go ahead and do an algebra example down here, number 4. It says TR is 2x minus 1, and MN is 19, and PA is 7x plus 3. And my job is to figure out what x is. I'm going to set up the same formula I've been setting up. The mid-segment, 19, should equal half the sum of base 1 plus base 2, which is 2x minus 1 and 7x plus 3. Now it's half of all of that sum, so that's separate from that. The simplest way to work with the 1/2, in my opinion, is to multiply both sides by 2. So you would say 38 has to equal that 2x minus 1 plus 7x plus 3. And now I can solve this equation. 38 is going to equal 9x plus 2, which means 36 is going to equal 9x, which means my x when I divide is going to equal 4. So the answer here would be 4. So again, the property didn't change, we just changed the algebra that we had to use to solve that particular problem. Now the next couple examples you see in your notes are proofs, and the goal of today is to have you do several proofs. So follow your agenda, make sure you try the proofs, but what I want to give you is the properties of the second figure, which we call a kite. Now the definition of a kite is a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. And when you mark that on the picture, this is what that means. You'll have one set of sides that are congruent connected to each other, and you'll have two more sides that are congruent connected to each other, but the sides across from each other will not be the same. And that forces you into what we call a kite. Now, one of the properties of a kite is that the opposite angles are congruent, but you only get one set, so I want to be clear. One set of opposite angles are congruent. And, to be a little more specific, it's always the angles connected by the shortest diagonal. And if you look at my kite, you can kind of see that. These two angles, E and I, look the same, whereas K and T do look different. T looks to be slightly smaller than angle K. So that's theorem number one. You have one set of opposite angles that are congruent, and it's always the angles connected by the shortest diagonal. Your second theorem is that if it's a quadrilateral, then the diagonals are perpendicular. And what that means is when you draw the two diagonals, they're going to meet perfectly at a 90-degree angle. So a lot of times I tell people the easiest way to draw a kite is to draw a straight segment vertical, draw a segment horizontal, and then you just connect all of those segments. Because now you're going to get that nice 90-degree, these two will be the same, these two will be the same, and you've drawn a kite. Again, I'm not showing you the proof because that's one of your assignments, is to show me why this has to be true based on the definition of kite. So now that you have the properties, we have a list of properties of parallelograms, rectangles, rhombus, square, trapezoid, and kite. I suggest you make a list of all the properties you know and then use those to answer the questions and to help you with the proofs. Good luck.